Hello guys, good morning.
Yes, sir.
Sir, I have a question about the notes.
Who is there? Yes.
What is type 2 of improper integrals? I couldn't read it. Just what does it say under type 2? Like, what is it called?
Did I teach you that article?
I'm sorry?
Did I teach you that article?
No, it's for today. I'm just wanting to write down my notebook.
I am going to let you know this thing. What is type 1 and type 2 improper integral? I have not started improper integral so far.
Oh, okay. Sorry, my bad.
Yeah, that's what I'm asking you. That did I teach you that article? No, we have not started that one. We are going to start today. Okay.
Okay.
How many exams we have finished, guys? Just 2 exams, right? 2 more exams to go. Am I right, guys?
Yes, sir.
Yes, sir.
Yes, sir, almost there.
Yeah, look at over here. Somehow the file which I downloaded, that's here. So that's why I need to go through this one. I've been working this thing since in the morning, but I don't know why it doesn't work. So let's just discuss this thing and let me try to let me scan these pages again and let me send it to you. Do we have any improper integral portion in our canvas? Yes or no? Let me check. I did not check canvas. Let me protect too. So improper integral and files and test 3 PDF. Let me start this one. Okay, fortunately, I think so. I am able to open this file. Okay, guys, got it. Let's start. I need to download this one. Okay, guys. Let me share my screen. Before I share my screen, I just want to see you guys. Veer Bhatt is here, Nick Tony is here, Matthew, Albert, Raj,
Here.
Thomas, Will, Virginia is here, okay. Then Jonathan Soto is here, Andrew Jarka is here, Christopher is here. Then Sheriff Chris is here, then Heavener is here, Ismail Taylor is here, Powell is here, Kabel is here, Alexis Davis is here, Lazara is here. Then Peton, are you there?
Yes, sir.
And still we are missing 4 or 5 guys. Why?
Sir, I'm
Sure.
here.
I'm here as well.
Oh,
I don't think we're missing anyone, sir.
they are not missing anyone? Will you please make sure, please, John? Please do that favor for me.
Okay.
Simon. Yeah, please do that favor for me, John, please.
How many people are in the class, sir?
Say again?
How many people are in the class, sir? 23? 22?
We have 22, yes.
22, then we're all here, all present.
All are here? Okay, so
Yes, sir.
good. Okay, guys, just look at over here now. We are going to start the last article of your previous chapter. I mean, it's the last article of chapter 6. And then after we will be switching over to chapter number 7. You have to be very, very, very attentive for chapter 7. Chapter 6, that was just the techniques of integration. But in chapter 7, we are going to see how the integration techniques are being used or are used in the real life problem. So that's what we are going to see. One more thing, this time I have downloaded all your problems, I mean to say practice test assignment with the solution. So please write it down, try to understand each and everything. Don't mess up the things. Please try to go through each and everything. Convince yourself. If you have some doubt, let me know, ask me, and we will discuss. But don't write anything blindly. Just for your sake of convenience, I'm providing you practice test with its solutions. So please don't try to misuse this facility. Please, I request you. Don't try to look at the solution first. Try to solve your examples first. If you are not getting the things, then try to compare your solution with the practice test solution. And that way you can learn. Because I don't want any one of you to lose your grades in this next exam. And that's why I'm helping you guys. Otherwise, I'm not supposed to post the solution of the practice test or homework on your canvas. But even though I'm doing that thing just for your sake of convenience, just to help you out. Okay, guys. So last article is improper integral. Make sure when you ask any of the questions at that time, it should not be out of the syllabus, right? I mean to say, if the article which I have not covered here in the class, please have patience. Don't ask those quick things. Once we go through that article, then after, of course, you can ask me 2, 3, 4 times. I don't mind. So improper integral. There are 2 types of improper integral. The first type is the infinite limit of integration. Whenever limit of integration, any one of the limits, either upper limit or lower limit or both. Look at over here, look at my cursor. All of you are able to see my page, my cursor?
Yes, sir.
Yes, sir.
Good, thank you.
Could you put it in full screen, sir?
I can't hear you, what you said?
Could you put it in full screen?
What's he said? I can't hear you clearly.
He's asking if you can put it in full screen.
Full screen? Oh, okay. Full screen, I don't know, because I just started. No.
It's the button all the way to the right with the
Yeah,
arrows.
it is. Huh. Doing. Why I'm not able to copy, select all, select, read about.
Sir, on the top bar on the far right, the arrows pointing outwards.
All
is
right,
the
let
green
me
button.
see. Yeah, let me see, please. Oh, yes. Is it okay, guys? And let me zoom a little bit. Is it okay?
Yes, sir. Looks good.
Yes, sir.
Good. Okay, guys. So just look at over here. Yeah, so there are two types of improper integral. One is either one of the limits or both, range of integration that is infinity, some fixed number a to infinity, or negative infinity to b, or negative infinity to infinity. That is called first type of integration. Second type of integration, you know that whenever we are taking the integration, at that time your function has to be continuous in the given interval, and that is the Riemann condition. Without continuity, you cannot integrate that function. But suppose your function has at least one discontinuous point, 1 point of discontinuity. Is it possible to integrate that function? Answer is yes. Yeah. If you have just one discontinuous point, in that case, you can, in the given range of integration, in the given interval, in that case, you can integrate that function. So please pay your full attention, guys. First of all, let me go through the type 1. Type 1, that means you can see over here, here it is somewhere A and here it is B. And whenever I'm looking for the integration of A to infinity, first of all, I need to A to infinity. This is my A and goes to infinity. Don't consider this one. A and then goes to infinity, goes to very high, large number. But whenever we are looking for the integration of this type of integral, at that time, we have to fix one point. It is your choice, one point. This B could be anything. B could be 100,000, million, trillion. It could be anything, right? But you have to fix one point. Once you fix that point, that means how can you fix the point? You cannot change the limit of integration. That means the best way is to apply the limit. So I can write like this: integration a to b of fx dx. That means this one. And because this b tends to infinity, let me apply the limit. So limit as b tends to infinity a to p fx dx. Right? Same here. Suppose you have negative infinity to b. So now here it is a, here it is b, and a tends to negative infinity. To get here, a tends to negative infinity. So I'm going to fix one point like this, b a over here. The upper range b is a real number, so that is fixed, so we don't have any problem. On the lower range, you can see over here, that is negative infinity we want. So we are fixing one point over here on the real line, negative side. And then after we allow a tends to negative infinity. So whenever you have negative infinity to b, at that time, we are going to write integration a to b fx dx, where a, limit of a, that goes to negative infinity. And whenever we have, suppose both sides negative infinity to positive infinity, you cannot work with negative infinity to positive infinity, both the limits infinite simultaneously. In that case, we have to have one point which has to be continuous. Function must be continuous at this point C. You have to pick one point over here, C. Usually we are looking for that point near 0, 0, negative 1, 1, like this. So usually we are looking that thing. Right? So you have to fix one point like this, so that here, the range over here, please try to look at my cursor. The range over here, that is negative infinity to C, and then it goes to C to infinity. Negative infinity to C and C to infinity. This negative infinity to C, that is of this type. Look at over here, negative infinity to B. B is fixed, C is fixed. So negative infinity to, that means that is this type. And this C to infinity, that is a first type. C to infinity, upper range is infinity. That means this negative infinity to infinity is nothing but the combination, or you can say addition, of these two integrals. Negative infinity to b plus b to infinity, or you can say negative infinity to c and then c to infinity. That means here to here and then here to here. And once you are working with this negative part, just apply this technique: fixed one point over here, fixed one point over here. Look at here. Then I can take this negative infinity to c, I can consider as a to c, where limit of a goes to negative infinity, and integration of c to b of fx, and where limit of b upper limit goes to infinity. So that's how we can solve the examples. Please look at over here, and very frequently we will be using your integration techniques, whatever you have gone through in article 6.1 to 6.67, what it may be. So this is the last article of your syllabus. Please be careful. First example. Now I'm going to take the examples based on this type 1, and then after we'll go through type 2, where we will be having at least one point of discontinuity. So type 1. Suppose we are looking for integration 1 to infinity 1 over x dx. 1 to infinity 1 over x dx. Now you can see over here 1 to infinity, that means here to here, 1 to infinity. Whenever you have this type of function, or that, first of all, try to make sure that your function is continuous in the given domain, is continuous in the given range of integration in the given interval. So here 1 to infinity, if I take x equal to 0, 1 over 0 is infinity. Lx is here, please. If I take 1 over 0, 0 is equal to 1 over 0 means it is infinity. That means function is not defined. But you can see 0 I have chosen, that is not from this range of integration. My range starts from 1. It doesn't start with 0. It starts from 1 and goes to infinity. That means if I take x equal to 1, 1 over 1 is 1, well defined. 1 over 2, 1 over 3, 1 over 4, 1 over 5. So 1 over 1, 2, 3, 4, 5, it goes to, for very large number also, right? See, it goes to infinity. So that means for all these values, the function is well defined, but the function is not defined over here. Function is well defined. And finally, if I take 1 over infinity, if I take very large number, suppose 1 over 1 trillion, in that case, you will be absolutely nearer to 0 from right side, because we are moving like this. 1 over 1, that is equal to 1, 1, then 1 by 2, 1 by 2 is 0.5, 1 by 3, 1 by 4, 1 by 5, like this. And we are moving, we are approaching to 0. Right, guys? We are approaching to 0. Look at over here. So for 1, 2, 3, 4, if you take 1, value is 1 here for y-axis. If you take 2, value is 1 by 2. If you take 3, value is 1 by 3. If you take 1 over 1000, value is very 0.0001, very nearer to 0. If you take 1 over 10,000, again nearer to 0. 1 trillion, again absolutely nearer to 0, but it will not touch exactly this point, right? Absolutely nearer to 0. Very, very, very nearer to 0. Right, guys? So that is the thing. So 1 over x, if you plot the graph like this, range is 1 to infinity. So 1 to infinity, because as I told you, that is your first type of integration. Lower range is fixed, upper range is infinity. So I would like to fix one point over here, b, and then after I will allow this b tends to infinity. So that's what I'm doing over here. I fixed one point b and limit b tends to infinity 1 over x dx. 1 over x integration is ln of x. So just first solve this one, this part, this ln of x. Once you solve ln of x, that means 1 to b, plug this value over here. For second fundamental theorem of calculus, x is replaced by upper limit and then lower limit, in between negative sign. So ln of b minus ln of 0. Ln of 0 is ln of 1. Ln of 1 is 0. So it is simply ln of b. Ln of b and b tends to infinity. Ln infinity is infinity. That means this takes the area bounded by this function 1 over x, graph of the function 1 over x, between the range of 1 to infinity, that is infinity. That is infinity. Now, whenever in the next chapter, or not next chapter, last chapter, we are going to see the infinite series. Infinite series is also the same type of series. Right now, we stop over here. Ln infinity equal to infinity. Stop here. But whenever, once we cover the last chapter, the whole syllabus is done. In that case, again, I will go back to this improper integral. And I would say that whenever this is a series actually. So whenever your answer is either plus infinity or minus infinity, means your series is divergent. I will let you know what we mean by the sequence, series, all these things, maybe after a week or like this. But right now, whenever you can say like this, because this is nothing but the area under the curve bounded by these two lines, x equal to 1 and x equal to infinity, or b, and b tends to infinity. So area under this curve, that is infinity. And because that is infinity not defined, and that's why this series of this function is divergent. Again, I will let you know the sequence series, all these things, and we will be doing lots of examples in the last chapter. But right now, just keep in mind this thing. If you are getting answer as either plus infinity or minus infinity, it is divergent, otherwise it is convergent. If you are getting any real number instead of this plus or minus infinity, that means it is convergent. If it is plus or minus infinity, it is divergent. Just keep in mind this thing. My second example, e to the power negative x. E to the power negative x starts with 0 to infinity, 0 to infinity. Okay. So again, now you can see upper limit is infinity. So let me fix my upper limit, 0 to b e to the power negative x, and b tends to infinity. So limit b tends to infinity, integration of negative x is e to the power negative x divided by negative 1. So let me put my negative sign over here. And range is 0 to b, 1 over e to the power x. Negative side, I just pull it out. So just take this one out, and 1 over e to the power x, 0 to b. Replace your x by upper limit and the lower limit, second fundamental theorem of calculus. So 1 over e to the power b minus 1. E to the power 0 is 1, 1 over 1 is, e to the power 0 is 1, 1 over 1 is 1. So let me write 1 over here. And if you take b tends to infinity, so e to the power infinity is infinity. So 1 over infinity is 0. So this part is 0. This is negative 1. This is 0. This is negative 1. And that's why this negative and negative is positive, because already you are having one negative sign outside. So it is positive 1. So this is the area. Because this 1 is a real number, fixed real number, that's why series is convergent. And that's why I change my pen. Look at over here, this is a darker pen, because this is not the part of this chapter. But yeah, after learning the last chapter, we can add that portion over here and try to figure it out, what is the area of, or what this infinite series will look like, whether it is convergent or divergent, whatever it may be. Next one, 1 over x squared plus 1. And you can see over here, I'm using my simple u sub over here, negative x equal to u, or like this, right? Simple techniques of integration. Now, suppose I want to go for integration 0 to infinity 1 over x squared plus 1 dx. Now 1 over x squared plus 1, once you look at the integrand, or you can, once you look at the function, you can come to know this thing, that which type of integration is there and which is the best technique to get the integration of this function. So again, upper limit is infinity. Let me plug b over here, fixed one b over here, and then after I can pass the limit as b tends to infinity. So limit b tends to infinity, 0 to b, 1 over x squared plus 1 dx. What is the integration of 1 over x squared plus 1, guys? Derivative of tangent inverse x is 1 over x square, am I right, plus 1.
Yes.
Integration of 1 over x square plus 1 is tangent inverse of x, right? Tangent inverse of x. So integration 1 over x square plus a square, and suppose here it is 1, actually formula is like this, integration 1 over x square plus a square equal to 1 over a tangent inverse x. But a is 1 here, so 1 over a, it is 1 over 1. No need to write, and that's why it is simply tangent inverse of x, and 0 to b. That is equal to tangent inverse of b minus tangent inverse of 0. Okay, now you have to be careful. How can you find? If you pass the limit, b tends to infinity, so tangent inverse infinity minus tangent inverse 0. How can I find tangent inverse infinity? And what is the value? Look at over here, guys. Whenever you want to find the value like this, at that time, you have to be very careful. I think this is first time probably I'm teaching you. So let me do one thing. Let me close this. Let me stop this sharing and let me start my tablet so that we can find the value of tangent inverse infinity and tangent inverse 0. So let me stop this one. Then let me go for sharing my tablet. So this is the whiteboard. Now let me start with this one. Okay. So I'm finding the value of, please try to look at over here, guys. Okay, so it says that tangent inverse of infinity, we are looking for tangent inverse inverse of infinity. We are looking for this thing. Suppose we don't know this value. I would like to write this value x. That means I will be looking for x. This implies that I can write tangent of x. If you take multiply by tangent functions both the sides, so tangent of x equal to infinity. This implies that tangent x is nothing but sine x divided by cosine x, and that is equal to infinity. Which value of x will provide me sine over cosine equal to infinity? Infinity means you are looking for 1 over 0. Means which value of x will provide me 1 for sine and 0 for cosine if I take x is equal to pi over 2. Am I right? Because sine pi over 2, sine of pi over 2, that is equal to 1, and cosine of pi over 2, cosine of pi over 2, that is equal to 0, and that is equal to infinity. Means pi by 2 is the only value which satisfies this equation. That means just go back and plug that value over here. That means tangent inverse of infinity, that is equal to pi over 2. Does it make sense? I'm asking all you guys. Does it make sense?
Yes, sir.
Okay.
Sir, I don't understand how you got the where.
Speak clearly. I can't hear you. Who is there?
Sir, how'd you get the pi over 2?
That's what I explained to you. Where are you?
I've been here.
Look at here. Tangent inverse infinity, right?
Yeah.
Is equal, you're looking for this value. Suppose you don't know this value. So let me put one x over here. The tangent inverse infinity equal to x. And we will be finding value of this x. If I multiply both sides by tangent function, so tangent inverse and tangent will get cancelled out, and I'm getting simply infinity. Let me write that infinity to my right side. Tangent of x on my left side, or either way, both are same. Tangent x is now written as sine x over cosine x, and infinity equal to 1 over 0. That means I am looking for that value of x, that particular value of x, which satisfies this equation. Means sine x equal to 1 and cosine x equal to 0. Only if you look at the unit circle, on your page 2, your unit circle on the page 2 is something like this. Oops. What? Huh. Stupid. Unit circle is something like this. Okay. Now, is the unit circle. This is the value 1, 0. 1 stands for cosine. This is 0. This one is pi by 2. This one is pi. And this one is 3 pi by 2. This is 1, 0 value. This value is strong. This one. Let me draw this one over here. I think this is better, probably. Okay. So this is my unit circle. This is 1, 0. This one is 0, 1. This is -1 and 0, and this one is 0 and -1, right? Because it's a unit circle. So this is my 0, 0. This value is 0. This is pi over 2. This is pi, and this one is 3 pi by 2. And then after I can go back. So 0 is nothing but my 2 pi also. So first value stands for cosine. Second value stands for sine. So I would say that cosine of 0 equal to 1 and sine of 0 equal to 0. Sine of 0 equal to 0, right? So that's what I told you over here, that if you take sine pi by 2, so sine pi by 2, you can see here, sine pi by 2 is 1 here, cosine pi by 2 is 0 here, cosine pi by 2 is, no voice please. Yeah, so if you look at here we have sine of pi over 2, sine of pi over 2, that is equal to 1, and cosine of pi over 2, that is equal to 0. So only x equal to pi by 2 satisfies this equation. So let me just go back and plug it over here. So tangent inverse x equal to pi by 2. Same way, suppose I want to find the another value, and that value is, suppose tangent. What was the next value? Tangent inverse of? Yes, please. What was the value? We were looking for tangent.
5/2, sir.
Tangent inverse of 1. Am I right?
Yes, sir.
Now, tangent inverse of 1, same way. Suppose we don't know. So let me write y. So if I multiply both the sides by tangent function, so tangent inverse of 1, that is equal to tangent of y. That means this will get cancelled out. I'm going to get tangent of y, that is equal to 1. But tangent y is sine y divided by cosine y, and that is equal to 1. So 1, that means I can write 1 divided by 1 like this. So which value of y will satisfy this equation? Where 1 means, if you look at your unit circle, you have one line over here. Please try to look at my unit circle. Try to look at my pen. You have one line over here, and this makes the angle pi by 4. This angle pi by 4, and if you look at over here, the first value is 1 over root 2, second value is 1 over root 2. That means sine and cosine, they are taking the same values. So if I take, suppose, because I'm looking for same value for sine and cosine over here. So if I take, suppose, y is equal to pi over 4. So y equal to pi over 4 means sine pi over 4 is 1 over root 2. Cosine pi over 4 is 1 over root 2. 1 over root 2, 1 over root 2 will get cancelled out. You are getting 1 over 1, and that is equal to 1. That means my y equal to pi by 4 is the proper value. Go back and plug that value over here. That means I can say that tangent inverse of 1, that is equal to pi over 4. Is it okay, guys?
Yes, sir.
1, that is equal to pi over 4. You will not find this type of calculation in any of the books. So please pay attention. If you have some doubt, you can ask me. This is our technique, you can say. So tangent, if you want, you can take the picture of this one, because you are going to use this type of stuff many times, probably in your Calc 3. So please, please, please make sure. Okay, guys, may I erase this part? So stop sharing, okay? Stop sharing, and let me again share my screen with you. So my third example, look at over here. It was tangent inverse 0. Tangent inverse 0 is almost the same thing. Tangent inverse 0 equal to, suppose, x. So it is tangent x equal to 0, means sine x over cosine x equal to 0. Only x equal to pi by x equal to 0 will satisfy this condition, because sine 0 is 0, cosine 0 is 1. 0 over 1 is 0. So it is pi by 2 minus 0 is pi by 2. Right? And I explained to you over here too. Look at over here. If you forget that part, only I wrote it down over here. I explained the unit circle, everything I explained over here. Now let's go. So do you have any doubt till example number 3, guys? If you have any doubt, please ask me. Otherwise, allow me to proceed further. Is it okay? Yes or no, guys?
Yes, sir.
Good. Good. So yeah, let's go for the next example. Next example is integration 1 to infinity 1 minus x e to the power negative x dx. Forget about this. Suppose I give you 1 to 2. 1 to 2. How can you integrate this function? Actually, it's a product of two functions. One is algebraic function, one is the exponential function. That means one has to go through Liet rule, because the product of two functions, so u into v rule. You can see my algebraic function stands first, so that's why u is there. Exponential function stands last, so that is my v. U into v rule says that in derivative of u, that is, u as it is, so 1 minus x as it is, and integration e to the power negative x is e to the power negative x divided by negative 1. So negative 1 is here. Minus, under the sign of integral, derivative of 1 minus x is simply derivative of, yes, what is the derivative of 1 minus x? Derivative of 1 minus x is negative 1. So here it is negative. Can you see my screen, guys?
Yes, sir.
Yes, sir.
Okay. So here it is negative 1. And integration of e to the power negative x is e to the power negative x divided by negative 1. So this negative 1, wherever my cursor is right now, this negative 1 will become positive. So that's why I wrote it down plus 1. So it's not just 1, actually it is plus 1 because it was previously -1 over here by the derivative of u function and integration of v function, that is another -1. This negative will become positive. That's why I wrote it down like this. Good. Now, whenever you want to apply this definite integral, because now it is definite integral, indefinite integral is now converted to definite integral by choosing one b, one fixed point b. So I can write, because this term is independent of integral sign, so let me write 1 to b. And this term is that includes the integral sign, so let me write 1 to b over here. You can apply fundamental theorem of calculus, second theorem. So it is x is replaced by upper limit, so 1 minus b to the power negative b. And if you replace x by lower limit, 1 minus 1 is 0, no need to write. So just write 0. Okay. Here it is just e to the power negative x, integration is e to the power negative x divided by -1. But -1 is constant, pull it out. So this negative sign converts to positive sign. This negative sign is converted to positive sign. So e to the power negative x, and my range is 1 to b, 1 to b. E to the power negative x can be written as 1 over e to the power x. 1 over e to the power negative x can be written as 1 over e to the power x. Right, guys? 1 over e to the power x. Look at here, guys. 1 over e to the power x. Now, 1 over e to the power x. Now you can apply x tends to b, or x equal to b upper limit. So 1 over e to the power b minus 1 over e to the power 1 is just 1 over e. That is my this part. But what will happen over here? See here, your range of integration. Here it is b minus 1 and e to the power negative b. B minus 1. If you separate them out, this b tends to infinity here and b tends to infinity here. That's fine. See, that's what I did over here. B tends to infinity. If you separate out. But here, please pay attention, guys. 1 minus b to the power negative b. If you take b tends to infinity, 1 minus b. 1 minus b is infinity. So 1 minus negative infinity means this part. Look at my cursor. This part is negative infinity. This negative infinity multiplied by negative sign means is positive infinity. It is positive infinity. E to the power b is, if b tends to infinity, e to the power negative infinity means 1 over e to the power infinity. Means 1 over infinity. Means it is 0. So this is of the form, indeterminate form, last article of your second test, indeterminate form, infinity times 0. Infinity times 0. That means we have to convert this form in any one of the standard forms, either 0 over 0 or infinity over infinity. So let me arrange the term in such a way that I'm going to get now infinity over infinity. So this negative sign, let me pull this one. Let me take this one inside. So it is b minus 1. And e to the power negative b is now e to the power b. E to the power b. So b minus 1 over e to the power b. If you pass the limit now, b tends to infinity. So infinity minus 1 is infinity. E to the power b is infinity. That is infinity over infinity. Means now it is in the standard indeterminate form. And that means I can apply L'Hopital's rule. So let me take the derivative of b minus 1 with respect to b. So it's simply 1. E to the power b derivative is e to the power b. So now it is 1 over e to the power b. And if you pass the limit now, e to the power b is infinity. 1 over infinity is 0. So this first part is 0. If you pass the limit for the second part, it is easy. 1 over infinity. E to the power infinity is infinity. 1 over infinity is 0. So second part will be 0. And here this term is independent of b. So simply 1 over e. Simply 1 over e. So negative 1 over e. And 1 over e is nothing but 2.7271 irrational number. You know this thing. So if you use your calculator, you're going to get 1 negative area. Something negative something. Why this is negative? Because your figure, this function, lies below x-axis. Just recall your chapter number 5, very first lecture. I gave you few figures and I told you that if you are getting the figure of the definite integral above x-axis means it is positive area, below x-axis means you are getting negative area. So negative of the numbers. Again, but this one is a fixed number because negative 1 over something, because it is approaching to 0. It is approaching, look at here, it is approaching to 0. Look at here, it is approaching to 0 line. Y equal to 0 line. And that's why this one is convergent. So this series is also convergent because you are getting some fixed number, whether it's positive or negative, but fixed number. And that's why it is convergent. So that's why this example is important, because we first used the Liat rule, L-I-A-T-E, and then after we have used the indeterminate form in the same example. So this example is a combination of two articles, whatever we learned in our last chapter, article 6.2 and 6.6. Any doubt? Any doubt? I'm asking you guys, any doubt?
No, sir.
No, sir. One more thing, guys, I'm posting all the videos just for your convenience on YouTube. And if you don't want to go through the videos, then I think, why should I waste my time? If all you are going to look at the videos and all these things, then probably I think that makes sense to me to waste my time. I'm going to spare some time for you guys. But if you don't want to look at that thing, then in that case, I think it is not required, right? Otherwise, just try to make use of this facility. It's really very time consuming. You won't believe what it takes, because we have almost 1.5 to 2 hours class, and it takes at least 25 to 30 minutes for me to upload the videos. So every day I'm spending half an hour after the class, every day. So please try to respect my efforts and try to utilize this facility. Please, guys. Yeah, so many times you may stuck at some of the points. So please try to look at the video, try to refer the videos, try to listen to the videos carefully. You will be probably solving most of your doubts if you can carefully listen to the videos. So please make sure, guys. I'm just requesting you if it's possible. I'm trying my best to help you out, because this is just the first time experience, online experience, and online learning experience for you guys. For me, it's a first time teaching experience in my 22 years of career. Anyway, guys, let's go for the fifth one. At least find some time, at least 15, 20 minutes. I don't say that go through complete 1.5 hours. No, half an hour. Just listen to that thing in your spare time. If you are going for a walk in the garden in the evening, okay, you can do this thing. Open your YouTube on your cell phone and listen to this one. You will come to know so many things, guys. Simultaneously, you can do both of your jobs. You can just walking, make some light exercise, and simultaneously you can listen to these videos too. So that is called the time management. Anyway, guys, next one. So we finished the first two types, negative infinity to 0 and 0 to infinity. But now let me go through another part, that is negative infinity to infinity. My integrand, my function is e to the power negative x and 1 plus e to the power 2x. This is my function. Graph of the function is like this. You are not supposed to draw the graph of the function. This is just for your convenience and just to convince you that how this indefinite integral works, and we can find the area bounded by the infinite limit. Okay, so because it is like this is a continuous function at 0. So why not to choose 0? As I told you, always try to think about the point nearer to 0. But you have to make sure that whatever the point you are choosing, that function must be continuous at that point. You cannot choose the point at which your function is not continuous, right? Because still we are in the Riemann sum, we are working with the Riemann integration. So your function must be continuous in the given defined integral. So let me write like this. This negative infinity to infinity is divided into two parts. One is negative infinity to 0. Second one is 0 to infinity. Now negative infinity to 0, that is my first part. 0 to infinity is my second part. Lower limit is this one. So let me fix my point A on the negative side. So A to 0, where A tends to negative infinity, and 0 to B, where B tends to positive infinity. So now I am in the range of definite integral kind of things. That means now you can see I have to just solve this integral. How can I solve this integral? If I choose my u sub, suppose e to the power x equal to u. So e to the power x equal to u, so e to the power x dx equal to du. Dx equal to du. So plug these values over here. Now you have chosen your u substitution for your convenience. U was not given to you in the example. So that's why make sure that whatever the range you are writing over here, intentionally I wrote it down x equal to a to 0. My function integrand is in terms of u. So once you take the integration of 1 over 1 plus u square is tangent inverse of u, and x runs from a to 0, A2 0. Don't take this, don't replace this u by 0 because this is x, this is not u, this is x. Your range of integration, that is in terms of x. Your function is in terms of u. We took this u because we wanted to integrate the function. Now our purpose is solved. So just go back and try to plug the value of u. U was my e to the power x. Let me first go back to e to the power x. So tangent inverse of e to the power x. And then my limit of x equal to a to 0. Now I can replace this x by upper limit and lower limit and in between negative sign. Second fundamental theorem of calculus. Don't replace your u by 0 because it's not, 0 is not your u, 0 is your x actually. Okay, so tangent inverse of e to the power x, x equal to 0 to, sorry, a to 0. Now again the same thing guys, if you replace x by 0, e to the power 0 is 1, so tangent inverse 1. If you replace x by a, it is tangent inverse e to the power a. Tangent inverse 1, just we figure it out in our last previous example, that is tangent inverse 1 is nothing but pi by 2, right? Because it is tangent, sorry, it is pi by 4, sorry. Because tangent inverse 1 means it is sine x divided by cosine x equal to 1. And only x equal to pi over 4 gives you that value. Sine pi by 4 is 1 over root 2, cosine pi by 4 is 1 over root 2. 1 over root 2 divided by 1 over root 2 will get cancelled out and you are getting 1. So tangent inverse 1, I wrote it down over here again too. Look at here. Exactly same thing what we followed in the last example. So pi by 4. Good. Now tangent inverse e to the power a, but a tends to negative infinity. So tangent inverse e to the power a tends to negative infinity. So tangent inverse e to the power negative infinity. But e to the power negative infinity can be visualized as 1 over e to the power infinity. If you want to remove this negative sign, it could be considered as 1 over e to the power infinity. 1 over e to the power infinity is 1 over infinity. 1 over infinity is 0, means I'm getting tangent inverse 0. And tangent inverse 0 means we are taking sine 0 over cosine 0. And that is possible only of your x value is 0. So tangent inverse 0 equal to 0. Just like this way, you can write tangent inverse 0 equal to x. So tangent x equal to 0, sine x over cosine x equal to 0. Sine 0 is 0, cosine 0 is 1. So 0, 1, 1 is 0. That means tangent inverse 0 is 0. Right? So that is just my first integral. This is my first integral. Look at over here. Throughout the example, I did not touch my second integral. Now I can start with my second integral. So once I'm done with my first integral, keeping in mind this thing that I need some space over here on my right side to solve my second integral. So now let me start with my second integral. Limit b tends to infinity, 0 to b, 1 over 1 plus u square du. 1 over 1 plus u square and du. So limit b tends to infinity, tangent inverse x equal to a to b. X is equal to a to b. Right guys? Because 1 over 1 plus u square is tangent inverse of u. And tangent inverse of u is nothing but u was your e to the power x. Because integration is done, let me replace my u by x. So tangent u to x. So tangent inverse of e to the power x 1 to b. So tangent inverse e to the power b minus tangent inverse e to the power 0 is 1. So tangent inverse of e to the power b, tangent b tends to infinity, tangent inverse infinity. And here it is tangent inverse 1 is pi by 4, like this one. Tangent inverse 1 is pi by 4. So tangent inverse infinity is pi by 2. I explained to you the same thing on my whiteboard, on my tablet. The tangent inverse of infinity is pi by 2 minus 0. Combine all these things. See, simultaneously I put plus, 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 plus signs everywhere. So here I got the value pi by 4. And here it's set for second, but it was 0. So pi by 4 plus pi by 4 plus pi by 2. Right? Pi by 4. Let me check. It was pi by 4 over here. Tangent inverse of infinity, that was that part. This part was 0. Tangent inverse infinity is pi by 2, right? And minus pi by 4 is there. I'm sorry. This minus pi by 4, I forgot to write it down over here. So tangent inverse infinity, it is actually pi by 4. So pi by 4 plus pi by 2 minus pi by 4. Minus pi by 4. This is minus pi by 4. So this pi by 4, you can see slightly crossed line. This pi by 4 negative sign and this positive pi by 4 gets cancelled out. I am getting pi by 2 as the answer because pi by 2 3.14 divided by 2 1.57 fixed real number means your series is convergent. Your series is convergent. Try to look at this example twice. I give you 2-3 minutes, all you guys, because once you are done with this example, I don't think that you will face any problem solving the improper integral of type 1. I give you 2 minutes. Please go through this one. And if you have any doubt, please let me know.
Sir, so where it says e to the negative infinity, that equals 0 in this equation. So tangent,
Which one?
inverse tangent 0.
Inverse tangent 0, where is it?
Oh, over here where it says negative e to the negative infinity.
This one?
Yes, sir.
Yeah. Look at here. Tangent inverse e to the power negative infinity, right? Now, e to the power negative infinity can be visualized as 1 over e to the power infinity. Agree?
Yes, sir.
And 1 over e to the power infinity is 1 over infinity. Agree?
Yes.
And 1 over infinity is 0. Agree?
Mm-hmm.
That's why it is tangent inverse 0.
Okay, that makes sense.
Good. And guys, 3 to 4 guys, they have sent the link or submitted their practice test to my email. Please don't use my email for this type of purposes, please. You have to submit your exam as well as your homework on Canvas so that I can grade both of them and I can have all the records, and you can see that one too.
Yes, sir. I agree with this statement, but Canvas last night was not allowing homework to be attached to the comments. I
Yes,
tried
sir.
for about 40 minutes last night, and it was not working for the whole 40 minutes. It would not allow me to submit it attached.
Is it working now?
No, I haven't
It
tried
still
this
isn't
morning.
working.
It still
Just-
doesn't work. It won't let
It doesn't work?
because it's closed, so we can't actually submit it.
No, yeah, because I think it was, I gave you the time limit till 3 p.m. or something like that. And that's
Yeah, and it wouldn't let it
yeah,
submit.
so you need to submit before that time, right?
Well, you gave us the until midnight last night, so I tried
Until
submitting.
midnight, then it should have worked. What's the problem?
It did not work.
Double check.
I brought
And
it
I will
up.
open the
So-
window. Yeah. I will double check and I will open the window.
Thank you very much, sir.
No problem. Yeah. But make sure all you guys, those who send email to me, please, you have to, please take this help from your colleagues, your friends. You can discuss over here to take the help. Ask the help from somebody, but you have to submit all of these things on Canvas, please. Okay, guys. May I proceed further?
Yes, sir.
Yes, sir.
or no? Okay. Okay, guys. So next part is the indefinite integral or improper integral, sorry, with infinite discontinuities. Look at here, 0 to 1, 1 over 3 square root of x, or x to the power 1/3. That's fine. Let me consider just 1 over x here, 1 over x. Now 1 over x, as I told you that you have to have your function continuous in the given range of integration. Here it is 0 to 1. My function is continuous throughout, except 0. Look at over here, because if I replace this x by 0, 1 over 0 is infinity. And infinity means 1 over 0 doesn't make sense. Right, guys? That means this 0 creates the infinite point. This 0 creates the point of discontinuity. Right? Improper integral of second type, that means you have a point of discontinuity, but that point of discontinuity should not be in the middle of the integral or middle of the interval. It should be either the initial point or the final point. If it is middle of the integral, no way, it's hard. Right? Of course you can do that thing, but right now my 0 is the initial point for which my function is not defined. So what I'm going to do, look at here, guys, please try to understand this thing. Why I'm getting this circle? I want my cursor. Anyway, so because my function is not defined at 0, so I just put open interval. Look at here, guys, open interval 0 and closed interval 1. Closed interval 1 means my function is continuous and 1 is included. My function is continuous throughout the range, but my 0 point is excluded. That means the point you are choosing very nearer to 0 from right side for all those points, suppose 1 over 1000, extremely nearer to 0, 1, 0.0001, 0.001, 0.0000001. For all this very, very, very small point nearer to 0, extremely nearer to 0, your function is continuous, but not at 0, not at 0. So I'm going to fix one point nearer to 0 from your right, because it's a positive limit from your right. So here. So let me fix one point A over here. A over here. And then after, what I'm going to take, see, but you have to make sure, because you cannot write A tends to 0 only. Now you have to mention that A is coming from in this direction, in this direction. A is coming from this direction. So it is A tends to 0 plus, because A comes from the right side of your 0, means A tends to 0 plus, and A to 1 and 1 over x to the third 1/3 dx. Now you can go for the integration. So x to the 1/3, it is x to the power negative 1/3, and derivative, integration is power rule, x to the power negative 1/3 plus 1 divided by negative 1/3 plus 1, means x to the power 2/3 and 2/3. Range is A to 1. Replace your x by 1. So this 2/3, you can take it out, you can pull it out. So here it will be 3 by 2. 3 by 2, limit A tends to 0, x to the power 2/3 minus x to the power 2/3, okay, and A to 1. So x to the power 2/3, x is replaced by 1. So here it is 1, and here it is A to the power 2/3. A to the power 2/3, right? And here it is 3 by 2. So 3 by 2, A tends to 0, 1 is constant, let me pull it out. Here A tends to 0, so this 0 to the power 2/3 is 0. So 1 times 3 by 2 is 3 by 2. That's a fixed real number, 1.5, convergent series. Convergent series. Sounds good? So that's how you can go over the second improper integral, or improper integral of type 2. Sometimes you will be having the combination of type 1 and type 2. we are going to do that type of example too. Now look at over here. Here in my first example, my 0 was the point of discontinuity and that was the initial point. But as I told you that it could be anything. It could be anywhere, I would say, anywhere in the given interval. In my second example, it is -1 to 2, -1 to 2. But in this -1 to 2, my function is well defined for if I replace x by -1, -1.5, everywhere, 1, 1.5, 2, everywhere, except 0. So 0 is the point of discontinuity. 0 is the point of discontinuity. That means I have to divide my range into two parts, -1 to 0 and 0 to 2. Make sure you don't have both the points discontinuous. Just one discontinuous point is allowed, but not both. So -1 is well-defined point, 2 is well-defined, but 0 is the point of discontinuity. So let me divide into two parts, 1 over x cubed and 0 to 2, -1 to 0 and 0 to 2. -1 to 0 and 0 to 2. The graph of the function will look like this one, where at 0 function is not defined. Good. Now this is a first type because this is 0, function is not defined. Not defined, that means I can take some b and b tends to, look at -1 to 0, -1 to 0. I am taking one b over here and then after I allow this b tends to 0, where b is not 0, b is a limit, b tends to 0. B is not exactly equal to 0, right? So once you have b means it -1 to b will be a definite integral. I can solve this definite integral and then after finally I can pass the limit as b tends to 0 minus. So 1 over x cubed integration is -1 by 2 and 1 over x square. Power rule, x to the power -3. So x to the power -2 and divided by that -2. Good. Replace your x by upper limit and lower limit. 1 over b square minus 1. 1 of b tends to 0. So 1 over 0, 0 minus. Please make sure this thing. B tends to 0 minus. So 1 over b square, right? That is -infinity and this is -1. And this is -1 by 2 out. So this is -infinity, negative, positive. This is positive infinity. My second integral is 1 over x cubed. Integration is same. -1 by 2, 1 over x square. A tends to now 0 plus because now I have fixed one point over here, a to 2, and now then after I allow this a, whatever a I fixed over here on the right side of 0, I allow that point to go to 0. So a tends to 0 plus. But this is now from right side, so it is plus. So please make sure about negative sign, positive sign, because I will be taking care of all these things in the exam. If you have not mentioned this positive or negative sign or simply 0, means you will be losing some points. So in mathematics, one has to be very precise in writing. Okay, so -1 by 2, constant, pull it out, 1 over x square, x is replaced by 2, so 1 over 4. Limit a tends to 0 plus and 1 over x is replaced by a, so a square. And a tends to 0 plus, so a tends to 0, 1 over 0 is infinity, so this is infinity. So I was getting infinity, -1 by 8 from here, and minus plus, and infinity divided by 2, again infinity. So infinity plus infinity, this plus, not minus, please keep in mind this thing, don't mix up the things. Infinity minus infinity is in the indeterminate form, it is infinity plus infinity. And they are separate terms, so don't worry about it. So it is 1 by 2, infinity plus 1 by 2 minus 1 by what it may be. But infinity minus something is again infinity. Because your answer is infinity, that means this series is divergent. This series is divergent, right? So I took first example in which my point of discontinuity started with the initial point 0. Second example, my point of discontinuity lies in the mid of, or in the middle of the interval, I would say, given interval. My third example, and probably that is the end of this article, improper integral. My third example, it lies like this. Look at over here, dx over square root of x, x plus 1. Now this is the example in which we will be having method 1 as well as method 2. So because you will be getting point of discontinuity and you will be getting the infinite limit too. Look at over here, upper limited infinity. That means at first sight, it looks that this is of type 1. It is. But if you consider lower limit x equal to 0, 0 multiplied 0 and 1. So 0 multiplied by 1, 0. So again, 1 over 0 is infinity. Means 0 is a point of discontinuity. So it's a combination of both methods. Infinity represents the first method. 0 point of discontinuity represents the second method. right? So first of all, you cannot work with both the things negatively. I mean to say both, one is in both improper limits, right? You have to have at least one fixed number, one real fixed number for which a function is continuous. So that's why what I'm going to do, range is 0 to infinity. So let me take one convenient point for which my function is continuous between the range of 0 to infinity. And that range is 0 to infinity. 0 to infinity works like this, 0 to infinity. But if I take suppose x equal to 1, so square root of 1 is 1, 1 plus 1 is 2, 1 over 2 is well defined. So function is well defined for 1. So let me divide my range from 0 to 1 and then 1 to infinity. So 0 to 1 and then 1 to infinity. Once you do this thing, that means this is my second type, because 0 is a point of discontinuity, 1 is a fixed real number, function is continuous at 1. This is my first type. Function is continuous over here, but the upper limit is infinity. So first type, upper limit infinity. Second type, 0 is a discontinuous point. That means 0, here 0 is a discontinuous point. So I can take one point just right to 0 for which my function is continuous. Suppose that point is a, and then I allow that a tends to 0 from right side. So a plus. A tends to 0 plus. And integration a to 1 over root x plus 1 dx. 1 over root x plus 1 dx. And the second part I can assume like this. Here it is 1, upper limit is infinity. So let me fix one point b over here, and then after I allow that b tends to infinity. So 1 to b and then b tends to infinity. I want to solve this integral now. Now the ball is in your court. I want to solve this integral. So it is root x equal to u. Means x equal to u square. So derivative is, or root x is 1 over 2 root x dx equal to du. So 1 over root x dx equal to 2 du. So 1 over root x, this part 1 over root x, look at my cursor. 1 over root x and dx is my du. And x equal to u square, so u square plus 1. So 1 over u square plus 1 and du. Whenever you have 1 over x square plus a square form, always you can take, you can go for arctangent, tangent inverse of x. So tangent inverse of x is the integration, tangent inverse of u is the integration. But my u was root x, so tangent inverse of root x, because range is range of integration. I forgot to mention here, but that is, oh, it's here. Range of integration is a to 1. So here it is a to 1, a to 1. Right, guys? So 2 limit a tends to 0 and tangent inverse of root x. So 1 minus tangent inverse of root a. Tangent inverse of 1, you know that thing, or you can keep right now like as it is, and tangent inverse of square root of a tends to 0, tangent inverse 0. Just keep it like that. Let's come to this point. Here it is tangent inverse, limit b tends to infinity, x equal to 1 to b. Again, u, 1 over root u is du, and x is u square, so u square plus 1, arctangent of root x, and b to 1. So let me write tangent inverse of root b tends to infinity, so tangent inverse infinity here, in between plus sign. So tangent inverse infinity multiplied by 2, so it is again infinity. Tangent, or you can take 2 out. Tangent inverse infinity. And now tangent inverse of 1. Tangent inverse 1 as it is. You can write tangent inverse 1 equal to pi by 4, I don't mind, but this pi by 4 and negative pi by 4 will get cancelled out. So just cancel it. You are getting tangent 2 times tangent inverse infinity minus tangent inverse 0. Tangent inverse infinity, again, just by our previous work. So tangent inverse infinity is pi by 2. Right? Because sine pi by 2 is 1, cosine pi by 2 is 0, 1 over 0 is infinity. So that is pi by 2. And tangent inverse 0 is equal to 0. Is 2 times pi by 2, 2 will get cancelled out. You are getting simply pi as the answer. Pi is 3.14 or 22 over 7, fixed real number, maybe rational or irrational, but real number. And that's why your series is convergent. So this last example, that is the example of the combination of both the methods. Any doubts so far?
No, sir.
Just look at this example twice, guys. Let me give you some time. Just look at this example twice. Sorry. And then we will start the next example. Just try around 1 p.m. because I have another class after this one. so that you can submit your homework online, and I will open that link for today. Okay, so just try.
Thank you, sir.
No problem. I am trying my best, guys. I don't know whether you will appreciate or not, but I'm trying my best. I gave you all practice tests in advance, and then after last time I gave you the solution too. This time I gave you solution in advance so that you can go through all the solutions of the practice test. You can take the help from me or somebody else, or you can look at the videos. And yeah, but see, hard work doesn't have any other option. There is no option for hard work. If you are a hard worker, that means you can do anything, whatever you want to achieve in the life. Yeah, intelligence comes through hard work. Very few people are born intelligent, God gifted. But for the general people, I think hard work is the only option to make your career, to get the good command over the subject, to get the things done well. So always keep in mind these things. Anyway, guys, so I think this is that. See, few examples are there. X times ln x, u into v rule, 1 over root x. We did this type of example. X square plus 1 is equal to u sub. X square plus 1 equal to u. Use u sub. So you can get this one very easily. E to the power negative x ln x, again it is u into v sub. Yeah, u into v. Liet rule. Right? One more thing here, you will be having 0 as a point of discontinuity. So please make sure its upper limit is in infinity, part type 1. Type 2, 0 is a point of discontinuity. So you have to have 0 to 1 and 1 to infinity. If you divide your integral in the range of 0 to 1 and 1 to infinity and proceed further just like my previous example like this, you will be done. So please try to go through these examples. Again, let me remind you, before you start any of these practice test or other homework examples, first of all, try to go through the examples, whatever we have covered in the class. Try to listen to my videos, try to look at these things, try to solve the examples by your own. If you stuck at some point, again, try to go to the solutions, whatever you have readily available readily. And then after, you can try the unsolved examples. That's the only way to get good command. Okay, guys, so that's the end of this chapter. This article, example based on this article will be asked in the next exam. Most likely, I would say Friday, day after tomorrow, or we will decide. I will let you know tomorrow when your next test is. But please work with me. Don't keep anything pending. If you think that you can work on weekends, forget it, guys. Forget it. There's a big difference between Calc 1 and Calc 2. This one is not Calc 1. And you might have realized this thing so far, right? Calc 1 is now, it's way easier than this Calc 2. It's just like this. Calc 1 is here, Calc 2 is here. And if you are done with Calc 2, that means you are, I told you so many times that that will help you a lot in your DFQ course. Your Calc 3 like this, mainly DFQ. So Calc 2, I would say that's the base for you, for the STEM majors. Okay, guys. Chapter 7, application of integration. Find the area enclosed by the curves f and g. If you remember, I intentionally did not go over the last example or last article of chapter 5. That was the area enclosed by two curves. Am I right? We skipped that article, and I told you that we are going to do that article as article number 7.1 in chapter 7. Do you remember this thing, guys?
Yes, sir.
Yes, sir.
Right, so I am still on my words. I am on that page, and this is the first one. Simultaneously, I just would like to request you to go through the problems of last section of practice test 1, because that was the same thing as example 1. Find the area enclosed by the curves f and g. So we are going to find the areas enclosed by these curves. That means we have to fix the range of integration and all these things, blah, 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 blah. But this chapter 7 will take some time. Yes, it will take some time. Right now it is, so there is no way. Okay, yeah. So chapter 7 will take some time. Chapter 7 will take some time. At least I would say today is Wednesday, Thursday, Friday, and 2 more days probably. Yeah, so let's see. But please work with me, guys. Otherwise, what will happen in this chapter? You know that if we go over example 1 and 2 today and again tomorrow, suppose you have not done anything today, and tomorrow I will be working with example number 3 and 4, you will be confused between yesterday's work and today's work. And you are going to mix up all the things and you will be messing up all your exam and everything. So I don't want to listen any kind of excuse. Spend some time daily. That's what I want. Yeah, I can only give the advice, guys. To follow the advice or not, that's your choice. It's your life, your course, your choice. Those who are working with me, I'm always ready to help them out. Always. Those who doesn't want to follow me, those who don't want to follow me, that's fine. I can't say anything. Choice is yours, guys. If you want to be my friend, okay, work with me. And you will be my good friend. Good. Second, find the area enclosed. Find the area enclosed by the region in 2 ways, or enclosed region in 2 ways, by treating the boundaries as a function of x. Treating the boundaries, this boundary as a function of x. Look at here, y equal to root x, y equal to, equations are given to you. Sometimes the equations will not be provided to you, just we will provide you the points. There's 2 and -1. So you need to find this 2 and -1. Here it is 0, 0. So find the equation of line. Here it is 2 and -1. Here it is 1 and 1. So find the equation of this line. So this is this. Here it is the curvature, y equal to root x, right? Between 0 to 1. 0 to 1. So sometimes this equation of lines will not be provided to you, or this curvature, these equations will not be provided to you. You need to figure it out by your own. You need to figure it out by your own. So please make sure. And same way over here, look at the curvature here is y equal to x equal to y square, or you can say y square equal to 2x. But this is the, by treating the boundaries as a function of y. This is a function of x, is a function of y, right? And you need to convert this one. Suppose once you are done with function of y, a function of x, then after you need to convert this one in function of y. Means x equal to y square. Here x equal to 3 minus y divided by 2. Here x equal to negative of 2y. And then you need to find the region. How to find this one, I will let you know. Same here. X is given. You need to go through this one and then convert to y. And again, find the area. Make sure both the ways you must get the same area. Both the ways you must get the same area. Find the areas of the triangle formed by the points 1, 1, 2, 2. Just see here. Just now I told you that I'm not going to provide you the figure like this, but find the area of the triangle. And 3 points are given to you. One is 1, 1. Then 2 and 3 is the another point. So 2 and 3 somewhere over here. So 1 and 1 is here. 2 and 3 somewhere over here. And 3 and 3 somewhere over here. So that's where you can find the triangle here. Okay. Now, most important thing in this chapter, that is the disk method and washer method, or disk washer method. Both actually are almost same. Slight difference is there. When your axis of revolution touches, I mean say when your figure touches the axis of revolution at that time, or your area touches the axis of revolution, we will be using disk method. Whenever your area does not touch the axis of revolution, at that time it is the washer method. So disk and washer method examples are here, and then after again disk and washer method, find the volume. That these are particularly for the volume. So how to find the volume? First 2 examples, these are based on the area. These are particularly for the volume, because now once we fixed one strip, and then after we are allowing the strip to move along your y-axis or x-axis, what it may be. If y-axis, it moves like this. X-axis, it moves like this, like this. So that means, suppose you have one region. Look at over here, guys. Suppose you have one region. Suppose from x and y-axis and parabola, right? Parabola. Now parabola is just region in 2-dimensional x and y-axis. But if I have x equal to 0 and x equal to 1, that means parabola is bounded by x equal to 0 and 1. And now I'm converting that parabola like this around x-axis. That means I'm converting my 2-dimensional figure to 3-dimensional figure. So I'm no more in 2-dimensional, but now I'm in 3-dimensional. That means we are finding the volume. So that is the purpose of disk washer and cell method. So just to find the volume. Make sure both ways you must get the same answer. Suppose I give you one example, and if I ask you use disk or washer method, you need to verify whether disk is appropriate or washer is appropriate. Any one of these two will work. And then after you have to solve the same example using cell method, and make sure you must get the same answer. If your answers are different, then something is wrong, because volume cannot be changed if you measure through disk method or washer method. Volume cannot be changed. Yeah, it can be changed if you are revolving your figure around x-axis or y-axis. Same example. And if you are using disk method or washer method, and if you are revolving your figure around x-axis and then y-axis, answers might be different. But if you are using both separate methods, just for one example, revolving your figure just both ways by x-axis, you must get the same answer. You must get the same answer. Disk and washer method. Okay. Good, guys. So let me start with example number 1. Example number 1, area enclosed by the curvature. Area enclosed by the curvature. Disk and washer we are not going to do today. That will be the part for tomorrow. So tomorrow, please have some stimulator before you come to the class. Okay, I need your full attention in tomorrow's class. Of course, in every class I need your attention, but tomorrow a little bit more. Right? Don't allow. If somebody wants to go out of our meeting, if somebody wants to leave the meeting for 5-7 minutes, please let me know first before you leave your chair. Please. Okay, guys. So first example, 2x squared plus 5x minus 3 and x squared plus 4x minus 1. Now, whenever you are solving the examples based on disk and washer, or I would say in short, chapter number 7, at that time, you have to make sure that you have to draw the picture. If you don't draw the picture, you will be almost wrong. You will be almost wrong. So please make sure that you have to draw the picture based on these examples. So draw the picture. Okay. Let me go through the first example. Fx equal to 2x squared plus 5x minus 3, x squared plus 4x. Two parabolas are given to you, but this figure is not given to you. Please keep in mind this thing. I am letting you know this thing right now, how to draw the picture. This is y equal to this one, y equal to this one. Two parabolas are provided to you. Let me equate these two parabolas. Look at over here. Let me equate these two equations just to figure it out, the point of intersections. Okay, so 2x squared plus 5x minus 3 equal to x squared plus 4x minus 1. X squared other side, it is 2x squared minus x squared is x squared. 5x minus 4x is x. Negative 3 minus 1 is negative 2 equal to 0. Quadratic equation. Factors are x plus 2 and x minus 1. FOIL method, x equal to negative 2 and 1. So your x intercepts, I would say, or x is negative 2 and 1. If you plug this negative 2 and 1, both of these x values, any one of these two equations, choice is yours. You will be getting the same thing. Suppose I take x is equal to negative 2 over here. So negative 2 square is 4. Negative 2 square is 4. Negative 2 is negative 8 minus 1 is negative 9. Negative 9 plus 4 is negative 5. So negative 2 and negative 5. Negative 2 and negative 5, that is the point of intersection for these two parabolas, negative 2 and negative 5. Look at over here, negative 2 and negative 5. Good. Second point was x equal to 1. Let me plug x equal to 1 over here. 1 plus 4 is 5 minus 1 is 4. So 1 and 4. 1 is my x point, 4 is my y point, so 1 and 4. This is the another point of intersection. Good. So I just figured out my points of intersections. Now, let me go for my first value, y equal to 2x squared plus 5x minus 3. Make one tabular form. But I'm going to say table. Take different values of x. Suppose I take x equal to 0, negative 1, negative 2, negative 3, plus 1, plus 2, plus 3. Usually take this type of points. Plug those points over here. If I take x equal to 0, I'm getting negative 3. So 0 and negative 3, x equal to 0, y is negative 3. X equal to 0, y equal to negative 3. Look at over here. 0, 1, 2, and 3. That means my curve will pass through this point. My curve or my parabola, this first one will pass through this point, 0 and -3. If I take x equal to 1, so 2 plus 5, 7 minus 3 is 4. So x equal to 1 is 4, that means it will go like this. So I can draw the curvature like this. I can draw curvature, it will go like this. Here, 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 and then pass through this one. Let me take one of the points from negative side. If I take x equal to -1, -1 square, 1, 2, it is 2. 2 minus 3, -1. X equal to -1, -5, -1, -5, -6. So -1 will go up to -6 over here. 1, 2, 3, 4, 5, and -6. Look at over here. This is 1 and -6. -6 over here. Then after that, we go through -2. Already you know that -2 is -1. So -2 is, what is the value? -5, right? So -2, if I take -2, y is -5. Here it was 1, -6, 2, -5. That means I started my curvature drawing like this, passing through this point, goes over here up to the bottom 6, and then after you have to turn like this because that makes your parabola. That's a parabola over here. So the equation is justified. That's the parabola. You can go like this. Actually, the parabola moves like this, like this. Here, starting from here, look at my cursor, goes like this, goes like this. Y-intercept, X-intercept is not required, that's fine. And then it goes like this, goes like this. Good. Then after same way for the second point, second parabola. Suppose I take x equal to 0, 0, 0, -1. So 0 and -1. Second parabola is 0 and -1. So 0, it will pass through 0 and -1. Look at my cursor, 0 and -1. If I take x is equal to suppose 1. So 1 plus 4 is 5 minus 1 is 4. So 1 and 4. So 1 and 4, that's a point of intersection. You know this thing, 1 and 4. So that means it will go like this, 1 and 4, and then it will pass through this point. So I'm from here to here right now. Let me take one of the points from this negative side, a couple points. -1 square is -1 square is +1 and -1 will get cancelled out, and -4. So for -1, I'm getting -4. -1, so 1, 2, 3, and 4, -4. So -1 and -4, that is somewhere over here. That means I'm extending my parabola from here, 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 up to here, up to here. Then after, let me take negative, x equal to -2. X equal to -2. If I take -2, already I figured it out, that is -5. X equal to -2, right? So it will go like this. It will go like this. So this way you can plot this curvature, both the parabolas, both quadratic equations, parabolas, and you can find the point of intersection by equating these two curves. Now, the question is how to find the area. Area enclosed by curve, area is given by capital A, that is equal to. Now you are taking integration with respect to x, make sure. That means you have to have your range with respect to x. Your x values are -2 and goes up to 1. So -2 to 1, -2 to 1. Don't consider your y values. Otherwise, you have to have everything in terms of y. Right? So your function of x, your y, this is your y equal to this one, y equal to this one. Formula is something like this. Let me share my screen again. Okay, let me skip this part. Let me erase this part. So clear my all drawing. And I was something like this. My graph was and it was moving like this. This was my point, -2 and -5, and this was my point, 1 and 4, right? So area enclosed by these curves, that means I'm looking for the area enclosed by this curve. I'm looking for this area. Now, area A is given by integration a to b f of x minus g of x dx. Make sure whatever you have upper function, this has to be your fx. And this bottom function must be your gx, because we are moving from top to bottom like this. And I'm considering one strip. This is my strip actually. This is my strip. Look at here. This is my strip, some random strip. This is my strip. This is my strip. Fx minus gx means, as I told you, that whenever you are integrating with respect to x, you have to move from top to bottom. So this is my top and this is my bottom. So I'm moving from top to bottom. If you are taking the integration with respect to y at that time, make sure that you are moving from left to right. So this is my left and this is my right. So please make sure. Here I'm moving from top to bottom. My top function, even though if you are given this one as g or this one as f, interchange that one. Because in the same example, I think this one is first part is given to you as fx. No, consider this as gx. Interchange it. And this one is fx because this is my top function. And that is why we require the figure. That is why we require a figure. Right? So this is my fx, this is my gx. My fx is this function. Anyone, will you please let me know the nature of this function? What was this function? X square, something I forgot. Give me both the functions, please. Any one of you, please.
X squared plus 4x minus 1.
X squared plus 4x minus 1. And what was my second function?
2x squared plus 5x minus 3.
Thank you. Minus 3. So x squared plus 4x minus 1, that is my, of course you are given g, but I would like to consider this is my f because that is at the top. So that is equal to x squared plus 4x minus 1. And this is my bottom function g. So I would like to consider this one as gx equal to 2x squared plus 5x minus 3. 2x squared plus 5x minus 3. So then after you can say, now this function is, that is equal to integration. My range is, because we have a function of x. So just try to pay attention, try to focus only on the range of x. So range of x runs from -2 to 1. So here I have -2 and here I have 1. And fx, just subtract these two functions in the given manner. I mean to say that x squared plus 4x minus 1 minus other side, it is 2x squared plus 5x minus 3, bracket complete. Simplify this function, I mean to say these two polynomials, and then after go for the integration. So what we are doing actually, we are right now taking one strip over here, one strip here, and then after I allow this strip to move over here at the initial point. And then after I allow this strip to move like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 blah. The strip is moving up to here, endpoint. Right? So this integration is nothing but the continuous summation, and that means we are allowing this strip from the initial point to final desired point to cover the whole area. And that's why we can find the area, and that's why it is called the area bounded by two curves. Area bounded by two curves. It is not just the area bounded by x or y axis. It is area between two curves, but area bounded by two curves. Any doubts, guys, so far? Any doubt so far? And
No, sir.
may I close this screen? May I close this screen?
Yes, sir.
Okay. So, oops. Share screening. Share screen. Okay. So here you can see that win, and then after I just went for the term by term integration, and finally I'm getting 9/2 as the answer. You know how to get this integration, just power rule. Right? So this is called the area between two curves. The rest of the things we are going to start tomorrow. Sounds good? Because
Yes, sir.
yeah,
Yes,
we
sir.
enough today. I don't want to give you more things so that you can get tensed. I don't want that thing. So that's why the rest of the things we are going to start tomorrow. So tomorrow what time?
6:45, 7:40, 9:45 your time. 7:45, excuse me.
7:45. All you guys
Sounds
agree
good.
with it? All you guys agree with him?
Yes, sir. That sounds
Sir.
good.
Yes,
That
sir.
works.
Okay, sounds good. So tomorrow, yeah, 7:40, we will start 7:40, 7:45. And sounds good. And we will continue from this point.
Perfect.
I'm extremely busy right now, guys. Yesterday I worked for almost 12 hours because after 7 to 12, 7:30 to 12, almost I'm teaching. And then after my lunch and 1 to 6, 7, I'm working for my research, all the stuffs. But I will find some time and try to grade your exams as soon as possible. And that's the reason I just want you guys to take your exam on Friday so that I can have at least some room, couple days to grade your exams. But I will try my best, okay, guys? Please, please, guys. It's extremely hard for me too because I don't know how to find the time, just like you guys. But I'm working. That's what I know. I'm working. Okay,
Yes, sir.
but please give me some time and I'll get back to you very soon. Thank you so much. Those who have not submitted their homework, please do it very quickly because once I start grading your exam simultaneously, I want to grade your homework too. I don't want to spare separate times to grade your homework. So please do it quickly. Once I start your statements and suppose somebody has not submitted a homework, he will be lose or she will be losing the points. So please do it as soon as possible. I'm going to open that window very soon.
Yes, sir. Thank you very much.
Thank you guys. Take care, stay safe and work hard. Okay. And again, try to go through the videos, guys. Please, I am doing these things for you guys. And if you don't utilize that thing, I'm getting disappointed. So please do that thing. If you want to subscribe, that's fine. Just click the icon so that you will be having all my videos in a chain, in a sequence. So please try to do that thing and I will see you tomorrow. Any question for me, guys?
Yeah, I have a question, sir.
Go ahead, Nick.
So I emailed you, but just in case you don't see it, I'm actually going to fly to Texas tomorrow, so I won't be able to go to class tomorrow morning.
Tomorrow?
Yes, sir. And the following Thursday.
Because
So the following.
tomorrow and day after tomorrow too?
No, sorry, like tomorrow, but then a week from tomorrow as well when I fly back home. So
Week from tomorrow, I don't know what we are going to do, but tomorrow is a very, very, very important class. So yeah, try to do something.
I can, well, that's what the videos are for. So I can just watch a video once I land. So.
Okay. Thank you. But please do it. Please do it.
Yes, sir. Thank you.
No problem. Any more questions, guys? Okay. So
No, sir.
take care and I'll see you. I will see you tomorrow. Thank you, guys.